Hello coders, thanks for joining me for part 2 of the top-down camera system tutorial series. Alright, so what we're going to be doing today is filling out the rest of our top-down camera script. In the last tutorial we went ahead and we drew out the skeleton for the script, so if you haven't seen that tutorial yet, you'll want to go ahead and check that out. I'll provide a link to it in the video for you guys to click. But anyway, what we're going to be doing is filling in the settings for our classes that we defined in the last tutorial, and we're going to be filling in the functionality for the functions that we defined also. Okay? Now, in the last tutorial, I didn't fill out these settings for you, but I thought I'd go ahead and add them so I can go ahead and talk about them in this tutorial. So you want to go ahead and pause the screen if you need to, or just listen as I talk about each one of these settings. Okay, so for our position settings class, what we want to do is add a distance from target. Distance from target is going to be used to determine the destination. It's going to help determining the destination vector that we defined before, and it's going to determine how high up in the sky we want our camera to be. Then we have a boolean called allow zoom. We set it to true. What this is going to do is enable the functionality of zooming in on the character and zooming out to see more of the scene. Then for the zooming, we have a few settings. We have the zoom smooth, so how fast do we want to zoom? And then we have our zoom step, so how far for each input do we want to zoom in? So I set that to 2. And what zoom step is going to be modifying directly is the distance from target. So by zoom step, I'm saying every time we increment, or every time we use the scrolling input, every time we use the zooming input, we're going to be incrementing or decrementing this value here. Then we have a max zoom and a min zoom. This is going to be our threshold, our zooming threshold, so we'll never be able to go closer than -30, and we'll never be able to go further away than -60. Alright. Then we have our smooth follow. So our smooth follow is going to be saying, do we want to log on to our destination, or do we want to travel to our destination over time? So if smooth follows to true, then we're going to be traveling to our destination over time, and our smooth setting is going to be how fast we want to go from our current position to our destination position. Okay, now I have this hide in inspector float because we don't need to see or modify this value from the inspector. And what this is, the new distance is going to be used for our zoom smoothing. And all it's doing is giving us, we're going to be using new distance to give us a destination zoom so that we can lerp towards that new distance. And again, our distance from target is going to be set to new distance whenever we're zooming. Alright, let's drop on down to our orbit settings. Our orbit settings are going to hold the current x rotation and current y rotation. I initialize the x rotation to -65. This is going to give us a nice angle on our x to look down onto our target with. And then the y rotation at -80 is going to place our camera initially behind our target. Then I have a boolean for allow orbit. So do we want the player to be able to press a button to orbit around the target? If that's set to true, then we're going to be using this y orbit smooth, which is how fast we want to orbit around our target whenever we're using that input. Our input settings are going to contain 2 strings, one for mouse orbit and one for zoom. Okay, now zoom is the axis for zoom is mouse scroll wheel, and you can set that to whatever you want really, but since I'm using the mouse, I set it to mouse scroll wheel. That's a default axis. Mouse orbit, I create an axis for mouse orbit. If you want to know how to do this, then let's go down to, let me get back to where I was there. Let's go back to Unity, and I'll show you how to add that input axis. We'll go to Edit, we'll go to Project Settings, and Input. Then over here on the right, you'll see several axes here. What you want to do is take whatever your current size is and increment it by 1. When you do that, you'll see a new axis show up here at the bottom. Now the one that we're creating is mouse orbit. So what I do is the default name of the axis that is added is going to be something else, so you'll want to go ahead and change the name to mouse orbit. And then I just set the positive button to mouse 0, which is going to be the left mouse button. So we're going to be using the left mouse button to orbit around our character. And once you do that, you'll want to make sure these settings are the same as mine as well. But once you do that, you'll be done with the input manager, and you can go back to your script and and once you do that, you'll be ready. You'll have the script hooked up to use the correct input setting. Alright, now since we have our settings all laid out now, we need to make sure we don't forget to add the references for these classes. So let's go ahead and add the references really quickly. We're going to have a public for our position settings, call it position, and set it equal to new position settings. We're going to have the same thing for our orbit settings and for our input settings. So input settings, input equals new input settings. Okay, once we have our references, we're finally ready to begin scripting the functionality of each one of our methods. Okay, so this is everything that I have so far. You guys should have as well. So let's go ahead and talk about what we're going to put into our start event function. So this is what we are going to be initializing some of our variables in. Let's say we set our camera target first. So first thing we're going to do is set camera target, and we're going to pass our target variable in. Remember, up at the top here we have this public transform target, and what I want to do in start is make sure that I set that camera target. Okay, and once I do that, I want to say if target. So if target is not equal to null, if target exists, I want to say move to target. And when I say move to target, all it's going to do is move my camera to its destination position right at the beginning, right whenever this function is, right whenever this script is first executed. Okay, so I'm just making sure it's in the correct place before we start updating. All right, and our set camera target is going to do exactly what it says it's going to do. So note that we pass a transform t as a parameter, and what we're going to be doing is setting our target variable equal to that. And then what we do is we say if target is equal to null. Okay, so if at this point target doesn't exist, we want to notify the user that their camera does not have a target to reference. So we're going to debug log an error. So log error, and we're going to say your camera needs a target, because at this point the camera should have a target if t was not equal to null. Okay, now get input, we're going to be setting our float input variables so that we know whenever our camera needs to respond to input. So what we're going to do is we're going to say our mouse orbit input is equal to input.getAxisRaw, and we're going to be passing input.mouseOrbit. So that's that string axis that we're passing to it. And so what's going to happen is that whenever we press that mouse 0, whenever we press the left mouse button, it's going to be returning a value into mouse orbit input. And then we're going to do the same thing for zoom input. So our zoom input is going to be equal to input.getAxisRaw, input.zoom. And remember that you don't need to do anything with this input axis. It's the way I initialized it was mouse scroll wheel, which is an axis that Unity provides for you by default. Okay, so that's our get input. That's all we need to do for our get input function. Now let's fill in the functions that we're going to be calling inside update and fixed update. Inside update, we're going to be calling get input, and then we're going to be checking to see if we want to zoom, if we're allowing our camera to zoom. So we're going to say if position.allowZoom. If this is true, if this boolean is set to true, if it's checked, then we're going to say zoom in on target. So we want to make sure that we call this function if and only if we are allowing our camera to zoom. Okay, now in our fixed update function, what we need to do is first check to see if we have a target. Since the functions that we're going to be calling inside fixed update require a target, we want to make sure that we check to see if our target exists first. So we say if target, which means if our target is not equal to null, then we're going to call a few functions. We're going to call move to target, we'll call look at target, we'll call mouse orbit target, and that's all we need to do in fixed update. So let's go ahead and fill in the functionality for these methods now. Okay, so move to target is responsible for getting our camera to move towards its destination position. So the first thing we need to do is set our destination vector 3. Remember, we initialized a destination vector 3 right here, and we're also going to be using this cam velocity right here. If we're smoothing to our destination position, we're going to be smoothing at this velocity. Okay, so we'll be using that inside this method as well. Okay, so the first thing we do is we set destination equal to our target's position. So we're initializing our destination at our target's position, but obviously our destination doesn't we don't want it to be at our target's position. Otherwise, if we did want it to be at our target's position, we wouldn't be able to see our target. So we want to make sure that we move our camera back out to where we want it to be looking with respect to our target's position. So what we're going to end up doing is moving our camera out and rotating it on the correct rotation axis. Okay, so what we're going to say is destination plus equal, so we're going to be adding to the target position, quaternion.Euler. We're going to say orbit.x rotation, orbit.y rotation, and 0. Okay, so let me explain what I'm doing here. Our goal is to rotate our camera around our target's position. That's why we initialized it to our target position. We want to rotate it around this point. So once we rotate our camera, we want to move it back by this value right here, position.distance from target. Okay, so at this point we've rotated it, but to get our rotated point turned into a vector 3, we have to multiply our quaternion by a vector 3. So we're going to multiply this by negative vector 3 dot forward times position dot distance from target. Okay, so what we've done is we initialized our destination to our target position, and what we're adding here is our rotation times a vector 3. And when you multiply quaternion by a vector 3, you get a vector 3 returned. And what this is it's the vector 3 dot since there is no vector 3 dot back as far as I'm concerned. There might be, I don't know. But what we're going to say is negative vector 3 dot forward because we want to move our camera backwards from our character's position. We're going to multiply that by distance from target so that we're moving back up into the air, and we are rotating the point right here. So we're rotating it about the target's position. So I hope that makes sense. I hope getting the destination isn't too confusing. But once you understand it, it really does make sense. Okay, so we have our destination, and now what we need to do is move our camera's position towards the destination. So first thing we do is we say if position dot smooth follow. So if we have this setting checked to where we want our camera to move towards our destination over time, then we want to make sure that we're smoothing towards that destination. So what we're going to say is transform.position is equal to vector3.smoothDamp, which is similar to lerp, but it's going to be a little bit more smooth. I've used lerp and I've used smoothDamp, and in my experience, smoothDamp is a little bit better. So again, it's somewhat similar to lerp. We're going to be passing our current position, our target position. We're going to be passing a vector 3 that holds the camera's velocity, and we're going to be giving it a smooth time. So how fast do we want this transaction to take place? So our current vector 3 is going to be transform.position. Our target is destination. Our current velocity is going to be ref cam velocity. So that's that vector 3 that we created up top. And then our smooth time is going to be position dot smooth. So our position dot smooth is, again, how fast do we want to go from our current position to our destination position. Okay, so all of this is if we have our smooth follow boolean set to true. If it's not set to true, that means that we want to just simply lock on to our destination position instantly. So all we have to say is transform.position is equal to destination. And that's going to complete our move to target function. Arguably the most difficult function inside this script. So once we have this, we know that we can get to our target position, but we still have the issue of being able to look at our target at all times. Okay, so that's going to bring us down to this method. So currently, if we just run the code with this method, so if we're just moving to the target, we're not actually going to be looking down on our character. We're just going to be looking actually into the default vector 3 forward direction. So we're just going to be looking at the sky. So what we need to make sure we do is we're looking down onto our character at all times. What we need to do first is define a target rotation. And we're going to set this to quaternion.lookRotation. LookRotation takes a vector 3 forward. The vector 3 forward is just the direction that we want our camera to look in. So to get the direction we want to look in, what we can do is subtract from our target position our current position. So we can say target position minus transform.position. and that's going to give us the vector 3 direction of our camera's position towards our target position. And then all we have to do is set our current rotation to the target rotation. So transform.rotation is equal to target rotation. And at this point, our camera is always going to be looking down onto our target. Okay, now that we have the move to target and the look at target function, we can deal with our mouse orbit target and our zoom in on target. But before I do that, I want to make sure that these functions are working. So I'm going to go ahead and run the game as it is, and I won't be able to orbit or zoom, but I should be able to see that everything else is working. So I should be looking at my target, and I should be moving with my target. Okay, so let's go ahead and run the game as it is. And if I switch my camera to top down, there we go, I'm actually looking down on my character and I am moving with my character. Okay, but currently I can't orbit and I can't zoom, so let's go ahead and add that functionality now. Okay, so to get my orbit functionality working, I need to first set values for my current mouse position and my previous mouse position. So if you remember up top in our settings, we created these vector 3s in the last tutorial, and we're finally going to be using those here. Okay, so let's start off by saying our previous mouse position is equal to our current mouse position, and our current mouse position is equal to vector 3, it's equal to input dot mouse position, so our current mouse position. Okay, so what we've done here is, if you imagine this runs through for the first time, we're going to set previous to current, which is going to be vector 3.0. We're going to set current to our actual input mouse position. Okay, and then what we're going to do is we're going to come back. The next time we come back in the next frame, we're going to set previous to our current, which was the previous frame's input mouse position, and then we're going to set our current mouse position to our new input mouse position. So all we're doing is we're making our previous mouse position equal to the input mouse position from the last frame, and we're setting our current mouse position to the mouse position of the current frame. Okay, so we have the previous mouse position of the last frame and we have the mouse position of the current frame. So now we need to figure out what to do with those inputs. Alright, so what we're going to do is we're going to first check to see if our mouse orbit input is greater than 0. And if this is true, that means that we're pressing our mouse button so we can actually start orbiting. And then what we're going to do is say orbit.yRotation plus equals current mouse position.x minus previous mouse position.x times orbit.yOrbitSmooth. Okay, so what we've done here is we're getting the x values of our previous and current mouse positions. And the reason we're doing this is because imagine if we are rotating on the y-axis, so if we're manipulating our y-axis rotation, that means that we're actually moving sort of in this horizontal motion around the character. And so since we're doing that, we're going to be getting the x-coordinate of our input.mouse position. So the left and right movements of our mouse position is going to manipulate the y rotation of our orbit. Okay, once we've done that, we're actually done with our mouse orbit target. So the only thing left to do now is our zoom in on target. Okay, so what we're going to do with this is, remember, we have our new distance member, and that is going to be giving us the destination zoom. So first we're going to be setting a new distance, and then we're going to be lerping to that new distance from our distance from target variable there. Okay, and so what we do first is we set the new distance. We say position.newDistance plus equals position.zoomStep. So how far each time we use the input do we want to zoom in? And we're going to multiply that by our zoom input. And the reason we multiply by zoom input is because if zoom input is negative, we're going to be zooming out, and if zoom input is positive, we're going to be zooming in. Okay, once we have our new distance, we're just going to modify our distance from target. And now I want to reiterate that we're using position.distance from target to set our destination position. So by modifying this value, we're actually going to be moving in towards our target or out from our target. So we're going to say our position.distance from target is going to be equal to mathf.lerp position. So our from position is going to be distance from target. So where are we moving from? And then our to vector 3, or our to float, so where are we moving to, is going to be position dot new distance. Now the speed that we want to go to and from those values is, or from and to those values, is going to be position dot zoom smooth times time dot delta time. Okay, so we want to multiply time dot delta time because if you remember, zoom in on target is getting called inside our update function, and so we want to make sure that we're using time dot delta time. Okay, so we are lerping to our distance from target, and once we do that, we are going to have the ability to zoom. But the problem is, if we leave it how it is right now, then we're going to be able to zoom way in past our character and zoom way away from our character. So we want to make sure that we maintain our distance threshold. Now if you remember up here in our settings, we have the min zoom and the max zoom, so we're going to be using those to constrain our distance from target variable. So what we're going to do is say if position dot distance from target is greater than position dot max zoom, then we have to do two things. We have to set our distance to target to our max zoom. So let's do that. Okay, and we also have to remember to set our new distance, because if we don't set our new distance, we'll be able to keep incrementing this value and we'll end up getting that value lost, and it'll look like our zoom function isn't working. So we want to make sure that if we're setting our distance from target to max zoom, we need to set our new distance to position.max zoom. Okay, and we're going to be doing the same thing for our min zoom. So we want to make sure if our position distance from target, if that's less than position.min zoom, then we want to make sure we're setting these values to our min zoom. Alright, and once we do that, we should be done with our top-down camera script. So let's go ahead and play around with it to test it to see if everything is working as expected. Okay, I'll go ahead and maximize on play so you guys can see this a little bit better. I'm going to select my camera to be top down. Alright, and so now I can zoom in. I'm trying to zoom in more, but I can't, so this is going to be my max zoom. And then my min zoom, I'm trying to zoom further out, but I can't, so this is going to be my minimum zoom. Alright, and I can move around with my target. My camera follows my target. I can rotate, orbit around my target, so everything is working just like we need it to, and our top-down camera is done. Okay, now there is one thing that I said that I was going to do with you guys, which is the character occluder. So you can see whenever I go behind objects, the object is fading out and I'm highlighting my character. Those are going to be some options that we end up doing in another tutorial. So let's look for the obstruction handler tutorial that's going to be coming up shortly after this. I'm going to teach you guys how to use this with your top-down controller. Okay, that's going to conclude this tutorial though. I hope you guys learned a lot. I hope you guys got it working. If you didn't, feel free to ask questions in the comment section below and I'll be happy to help you guys figure out whatever is giving you issues. Alright guys, but as always, this has been a Renaissance Coders tutorial. Thanks for watching and I'll see you in the next video.